let's look at the integral of secant of x. Now this again, like integral of tangent of x, may seem sort of harmless, and we may think that we already know it from the basics, but we actually don't, because here's what we do know. So we know our derivatives relate tangents and secants, and as far as the basic integrals in which we see secants, we only know secant squared x dx goes to tan x, plus c of course, and secant x tan x goes to secant x. So we don't actually have this in the basics that we should know. If we go ahead and do what we did for the tangent x and think of this as 1 over cosine x, if we try that, it doesn't really help because it's not really a u substitution. If I let this be u, du is going to be minus sine x, which I don't see here. So that's not going to work for me, the old methods of a u substitution. This integral actually involves a trick, and I use the trick because I've seen it before and I remember it. So you see a trick and then you remember it, and maybe you apply it in other places as well. But for right now, we're going to go ahead and use the trick. And the trick basically involves multiplying this integral by an equivalent funky looking one. Secant x plus tan x, secant x plus tan x. So what happened was we multiplied this by something over itself, which will end up being 1. And now we're going to go ahead and distribute and write it as a numerator and a denominator. So that'll give me secant squared x upstairs plus secant x tan x. That's something nice that I recognize. So this we like, and this we like as far as integrals are concerned, over secant x plus tan x. However, what happens here, of course, is if that's not all I end up with, because if that's all I ended up with, I could separate it into two integrals and use this guy over here. But I have that over all of this that I have to worry about. After that, what we actually do is a u substitution that magically makes things work really nice. We let u be the denominator. And then notice what happens when I try to get my du. Derivative of secant x is secant x tan x, plus derivative of tan x is secant squared x. So it actually had the denominator, which was fine. All these ideas sort of helped me out, because if I let u be the denominator, the du pretty much pops up what I have sitting in the numerator. So it becomes just a u sub problem, and again we let the denominator be u. All of this sitting in the numerator, of course, gave me my du. I'll put it over here. It's identical to my du, so I'll just put it over 1. And we know this is equal to ln of u plus c, but then u was this, so ln of secant x plus tangent x plus c is what I end up with. Finding the integral of cotangent x involves a similar move. Try to play around and figure that out on your own. So again, we multiplied it by an equivalent looking one, and if you've seen this for the first time and you're wondering where the heck is this coming from, yes, it's a trick that somebody came up with and it works out nicely. You've seen it once. Now next time hopefully you will remember and know how to use it or apply it to other problems.